I don't want November the 1st. Alright, a little bit tired at the moment, but we'll power it through. Let's power it through. Count unguarded. Oh, I need to reset. Basically means I did this not a long time ago. Count unguarded cells in the grid. You're given two integers m and representing zero indexed grid. You're also given two 2D integer arrays, guards and walls, where guards I and walls I represent the position of the ith guard and the jth wall. Ith guard and jth wall, respectively. A guard can see every cell in the four directions starting from their position unless, I remember this problem, unless obstructed by a wall or another guard. A cell is guarded if there is at least one guard that can see it. Return the number of unoccupied cells that are not guarded. I remember this problem, but I don't remember how I solved it, so let's solve it one more time. So we have a 4 by 6, so 4 rows, 6 column. Okay, so guard, I should follow wall, guard, wall. So basically, for each one, we just want to see if there is a guard in the four direction, right? That's what we want. Basically, what we want to know is when I'm at a position, right? When I'm at a position, I want to know the one to the left. Is that a guard or is that a wall? If it's a guard, then it's been occupied, right? And if it's a wall, that means it's not. So what I can do, if I got row by row, and I will go column by column. So I just check rows, right? So if we go, and then, but it's also need to be on the other side as well, because a row can be guard on both sides. Maybe not. Maybe we simply go from each guard. Okay, so for this guard, each guard we go all the way to the, because it's four directions, so all the way to the right, all the way down, all the way up, all the way left, and these are all guarded. Done. For this, these are guarded, these are guarded. You don't have to go here because this one's already guarded. Oh, this one's already guarded, but you still kind of have to go all the way through, right? Because if I have a guard here, so it needs to cross. It does need to cross. Okay, yeah, we'll cross. For this one, we have to cross, and cross. And then we'll go, so there's 1, right, 2, 3, 4, 5, 6, 7. So what's the impact on the runtime? So we just go as far as a wall, or there will be some crossover, but I don't think it will be too much, right? I don't think, because if you have lots of guard, once you hit a guard, you just stop. So the first guard will do all the work. But hold a second. So if I have a guard here and I have a guard here, so this go all the way down. So I hit a guard, so I say I'll stop. And so for this guard, I see this is, but I will keep going. So this path will get duplicated. So I think I also need the directions. So right, so I need directions. The direction will help. So let's say, let's say we just set, I don't know, let's call it 0, 1, 2, 3. So here going down, so I just set 3, 3, 3. And when I go up, right? When I go up, if it's, because up is 1, I actually don't like this. I think it'll be better if I just say, or what will be the best way? I want them to be kind of opposite to each other. So I know if the sum is 0, then you just don't go. But then if you cross, so if I have a cell that has been crossed and for both directions, we preserved 1. But hold on, that's also not. I mean, let me think again. So because you have to mark it a certain way that we know we don't repeat. I don't feel like this is the right. I still don't feel like that's the right way. Let me go back to the original idea of going through each cell and decide this. So we want to decide, like for this cell in particular, can it be seen? How do we decide that? So I know this is position 0, right? 0, 1, 2, 0, 2. So I just want to know on the first row and on the first column, do we have at least one guard? Right? Do we have one guard? And how do we know if we have one guard? We look at how many guards is on the 0th row that will be available, right? And how do we do that? Let's say we traverse it. So you're saying we go, let's say, left to right. Then we traverse again from right to left. So you're left to right. And then we do right to left. Okay. Yeah. So we have to do 4 times. Okay, I think 4 times will work. Right, 4 times will work. We can say guarded is 1, unguarded is 0. Right, unguarded is 0. And then a wall is yeah, so we'll go through guards, set up a guard. So I can say guard is equal to 1, wall is equal to 2, unguarded is equal to 0, right? So what we do is set a number. So guard is 1, 2, 1, 2, 1, 2. right? So I go left to right. If I keep the maximum, okay, say unguarded is the wall guarantees an unguard. Yeah, but if I have a 1 and it's not. So 1 is guard, 2 is unguard, so I set the situation becomes 0. So this will be 0, 0, 0, 0. Right? And then here, if we go left to right, so this will be 0. And this will be guarded. Alright, guarded. Maybe we pick a different number. So guard, I say guard is 2, and then guarded is 1. So this will be 2, this will be 3, 3, 2, and 3. So now this is 1, this is guarded, this is 2, which means it's guarded, so this will be 1, 1, this is a wall. So reset situation to 0, so this is 0. Right, this will be 0, 0, wall, guard, 1, 1. And then this will be 0, 0, 0, 0, 0, 0. This will go left to right. Right. Now we're gonna go right to left. 0, 0, 0. 0. This is a wall. So 0, but we take the maximum. Okay? So if it's guarded on one direction but unguarded on the other direction, so this will be 1. Right? So this, and I set this as 0, 0. Okay. Top down is guarded. So guarded, guarded. Top down, guarded, guarded. Top down, top down. This is guarded. Top down, top down. Bottom up, bottom up, bottom up, bottom up. This is actually also guarded. Bottom up, bottom up. So now we just need to count 0. So 1, 2, 3, 4, 5, 6, 7. Yeah, I have to go through them twice. So in total, I mean, I could just do this, 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 do this. It's totally fine. I'm not sure if that is the most efficient way of doing it, but I feel it shall be okay to solve this problem. It's like OMN. It will be very bad in runtime, I'm pretty sure, but yeah, I think you can get it done. Traverse. Alright, traverse the grid left to right, right to left, top to bottom, and bottom to top. Keep track of the state of each cell, whether it is guarded or not, right? Whether it is guarded or not. This is kind of brute force, and it will take OMN. And I need to create this one first. Grid, right? So it's M. Okay, and then for const auto g of gods, say grid g 0, g1 to 2, right? Guard equal to 2. For const auto wall grid wall 0 wall 1 3. Okay. And guarded to 1, unguarded to 0. So left to right and right to left. Let guarded I still wonder if it's possible to do it like twice. So like if we go this direction, right, this way, and then this way, this way, this way, technically at each cell we can both look from the left and we can also look from the from up, but we just need to figure out a way, like can we save a state, right, to know what the up look like. Because we go left to right, so if the left is a 1, which means it's been guarded, then you don't know, right? Because that one could be coming from down. So that's I kind of go back to this idea again, like we need some like directions, right? We need some directions to know if at a position it's coming from where, if it's guarded. Like it's a free, because I look at the left, it's hold on, let me think again. I feel like it can be done more easily. So like if we go left to right and we have a guard, okay, and then we have a wall. So if I look to the left, it's a wall, then I set myself as a 0. Okay? And then if I see the left is a 0, then I am also a 0 if we go left to right. But how about vertically? How do we control vertically? So vertically I'll look above me. Like if above me is guarded, then I need to know this guarded is going which direction, right? So if the direction is not going down, then I can remain. So I do need a direction. Okay, so we probably need a slightly different approach. Huh. Okay, so maybe let's redo this idea. So I have all directions. Say 1, 2, 3, and 4. Right, that's 4 directions. And if I'm in this direction, right, because I'm going left to right, so so but this, the problem of this is, what if you get monitored from both directions and you need to use one number to represent? A 4-bit number. A 4-bit number. This means it's free. So let's say this is going right. Yeah, this is going left. This is, hold on, it's like the Vim, right? So this is J. Oh my god, this is getting more interesting. This is H, this is J, this is K, this is L. L go this way, H go this way, J go up, and then K go down. Yep. So this is how we represent the state for each one. And we get negative. Let's get negative value for the wall. So I say guard. I don't know. Yeah, this is actually maybe an easier one. Guard. Let's say -1. Wall is -2. Okay, and then as we go left to right, well, default is 0, but we check the left, and then we know which direction it is. And if it's a negative, if it's -2, that means it's a wall, that we don't worry about it. And then if it's a -1, that means it's a guard. And because I'm going left to right, I know it directions this, so I set this bit, right? So basically the shift, right? This is the shift. Shift is 0, 1, 2, 3. That's the number of shift. Maybe we can use enum. I don't think we need necessarily using enum. I think we can use const expression for this, right? For this, it's just shift. And then, yeah, so we go left to right, we can get we can get it right, and then we can get down. Okay, yeah. And then if I look to the left, it's a positive, it's a non-negative value. Then I need to check. Basically, I check 4 times. Oh, you need to check 4 times. So every one of them, you need to check 4 times. You might as well just do the same thing. Like, right? You have to check 4 times. Yeah, you have to check 4 times for each one of them. Check 4 times. Because you need to know if... actually, you don't need to check 4 times. Because we are only looking for that direction. So you only need to check 1 time. Check for your direction. If your direction doesn't have a value, that means you're free. Right? You're free. You don't need to change. That is very interesting. Very interesting, which means the guard is actually not this, right? Because this guard just means I point to the left and then point down, right? So each guard is just a guard. Is just a 1 1 1 1. That is a guard. A guard is essentially 15. Right? That's a guard. A guard is 15. And a wall is a 0. No, wall cannot be 0 because otherwise we'll get double count. So we don't do 0 on the wall. But how do we, so we get wall, okay. So guard is this, wall I just set as a negative value. It's fine, right? It's fine. So basically, if I look, is a negative value, I don't worry, okay? And I look up a negative value, I don't worry. Otherwise, I need to check. Oh, this is actually okay, this is actually not that bad. All right, so guard is 1 1 1 1. Binary, okay. Right, so guard is essentially 15, and then there's a negative 1. So wall is negative 1. And I think I can do it. Let's go private. All right, so we have a private. Say int shift, right? Right shift. Not right shift. Yeah, right shift is 1. Left shift is no, right shift is 0. No, right shift. Shift for right, okay. Shift for left is 3, right? Shift for up is 2, and shift for down is 1. Right? Shift for down is 1. Okay, so it's a shift for left, for right. This is shift. What shift? Bit shift. Okay. Bit shift for left. Bit shift for up. Bit shift for down. Okay. So we're gonna go top left to bottom right. Right. We check for guard on the left and on the top. M I plus plus J0 J7 and J plus plus. We'll go through every single one of them, and what we do if grid 0 ij is not equal to 0, is equal to 0, right? Is equal to 0. This is the one that we need to check. Okay, is a check. If it's larger than 0, then we don't have to check. Actually, it's not true. I think everyone will need to check. It's just okay. So if it's equal to 15, okay, or grid ij is smaller than 0, yeah, this is when we continue, right? So these are, this is guard or wall, so we don't worry. Otherwise, okay, otherwise, then we need to check for the left, right? So we say check left. again, we should say if I is larger than 0. Okay, I is larger than 0 and grid I minus 1. Actually, this is actually for j, my bad. Grid I j minus 1, right? This is larger than 0. Right? If it's larger than 0, then we need to check. Right? We need to check. So what do we check? We just check for its bit. Right? We just check for its bit. And we can say int, right, if the bit is set or not set. So check left if this, check if the cell to the left is guarded from further left, right? Further left, which if the cell to the left has been guarded from left to right. Okay, this means hold on. Traverse the grid. Use a 4-bit number to represent from which direction, right? From which direction the guard comes from. Left, up, no, I think this one is down. This is up, right. It's coming from the this has to be decided, right? This is bit shift 4, monitoring coming from the right, okay, from the right, for monitoring coming from the left, monitoring coming from the up, monitoring coming from the down, right? So check the cell to the left has been guarded from the left, right? So from the left, so we just need to do and grid I j minus 1 and 1 left shift coming from the left. This, right? This is coming from the left. Does it have a bit for coming from the left? It's larger than 0. If it's true, that means we have to set as well. Then we say grid I j or equal to 1 left shift coming from the left, right? Similarly, we shall also check if the cell to the up has been guarded from the top, from the up. If I is larger than 0 and grid I minus 1j larger than 0 and grid I minus 1j and 1 left shift coming from the up, right? Then grid ij or equal to 1 left shift. Yeah, so for everyone, we go through this exercise to check if we have anything coming from the left. If it comes from the left, that means you will be monitored coming from the left, so you set yours as well. If it's coming from the up, we'll do the same. So we do that. We go one pass. So we set up all the stuff, and then if it's not right, if the cell it has nothing, then you don't do anything, and now we have to do the same thing. Okay, so this can be bottom right to top left. We check for guard on the right and the down. So almost the exact same, but we have to modify it a little bit. Right, I is large equal to 0, I minus minus. For j is equal to n minus 1. J larger equal to 0, and then j minus minus. Again, if grid I, j equal to 15, or grid I, j is smaller than 0. We'll continue. Yeah, guard or wall or the cell being monitored from all directions. Like this, we have nothing more to add in the scenario. Okay, now we'll check if the cell to the right has been guarded from the right. If j larger 0, right, and then grid actually this is not true. Right, and then grid I j plus 1 is larger than 0, and grid I j plus 1 and 1 left shift right, shift to right, right? So we have something from the right. If that's the case, grid ij, well, this 1 left shift this. Okay, and then we say check if the cell to the bottom has been guarded from the bottom. So if I is smaller than n minus 1 and grid I plus 1, j larger than 0 and grid I plus 1, j, and 1 left shift s down, right? I think that's what I call it. Yeah, s down. And grid ij or equal to 1 left shift s down. Okay, so when we go through all this, oh, we can also count here, but let's just do this at the end. So for equal to 0, I smaller than m plus 4 int j, 0 j smaller than n, j plus plus rest plus equal to grid I j equal to 0, and then we'll return rest. Okay, let's see. So we don't do 4 rounds. Let's see. This one is did I not include all? Holy crap, I think that's not right. Yeah, missed one. Oh, my bad. I forgot the private. Yeah, my bad. Forgot the private. Okay, look okay. Try it. Not too shabby. Not too shabby. 47 milliseconds. At 90.83%. Not bad at all. Not bad at all. Oh, Jesus. What the hell? What the hell? What the hell are you doing, man? Okay. All right. I'll check my solution in the past. We did in 2022. That was very convoluted. And what is this? Brute force mark so that whenever a guard is encountered, the current iteration ends. I'm still iterating it. Oh my goodness, look at this. Go right, go left, go up, go down. Yeah, 4 times, right? The 4 times. What I'm trying to do is not do it 4 times. I basically do it 2 times, right? That's what I was hoping for. Oh, this is Java. 2024, November. And then December. Oh, I think I redid it because I don't know why I redid it. As many cells as possible, we stop if we hit another guard or a cell that has been horizontally guarded. Then we go vertical, horizontal, and we have empty. Guard, else will break, and then we go right to left. So for each guard, we set the walls, and then for each guard, I horizontal, go as far as I can. Each one is guard. The break, and then we go right to left, try it again, and then vertical, and then we sum. Yep, that's the same idea. And this, I'm actually quite proud that I have this idea set up, a bit mask, right? So the bit mask, basically the guard can be generalized, right? Guard is generalized, and wall is not. And this only requires you to traverse it twice. The whole thing will go through twice. I don't have to. I mean, those are also going twice if you think about it. No, I mean it's not, because everyone is going. You go all the way down unless you hit. Hold on, it's saying that you start from here and you go, and you will break if it is not empty and it is guarded row. Okay, so basically it is just if you hit a guarded row, then you will skip, but if it's a guarded column, then you will continue. Okay, yeah. So I still consider this to go that's actually you do on a row, you don't overwrite because you skipped the that's the idea. It's okay. I like mine. Okay, I like mine. Maybe a little bit more verbose, but I like mine. Bit masking is always, it feels good. Feels very smart, honestly. Recursive. Nobody writes this recursive. Visibility axis. Yeah, we do have to go all the time, so I don't think there's anything special. Okay, yeah, that'll be it. I will see you guys tomorrow. Adios.